Hello, everyone. My name is Daniel Roberts. I'm in a group with Scout Basinski, Will Chiraz, and myself, and we are going to go over a problem where we're going to optimize a location for the Columbus Crew. So, getting right into it here. The problem in October of 2017, the Columbus Crew actually announced that they would like to relocate the Columbus Crew to a new city, essentially stating that because of the location, that the profits were not up to the MLS's standards, and they were trying to relocate them into a town or to an area that would be more profitable for them. If you guys watch the news, you'll actually know that this deal was negotiated, and they actually found a way to re-sign a deal in order to get the Columbus Crew, um, in order to keep them in Columbus. So, but we thought we would explore a possible solution in Columbus. If we were going to rebuild specifically in Columbus, we'd want to explore exactly where to put the stadium in order to minimize the distance from the stadium to other relevant spots in town that a person would be interested in being close to in order to incentivize them to go to the stadium, watch a game, spend their money, ipso facto, increase the profits for that stadium location. So, for the problem formulation, the decision variables we had were all Columbus restaurants, hotels, and code of bus stops. We used, for location, we used their longitude and latitude. Those are pretty easy and very accurate numerical locations for them. We wanted to find the longitude and latitude position for a specific point within Columbus that would minimize the distance between exactly 10 restaurants, 3 hotels, and 1 CODA bus stop. You can see by the objective function there that we wanted to minimize the sum of all of those distances. In order to find the ideal point, we wanted to find the minimum distance from those for every single point in Columbus. Unfortunately, Columbus has infinitely many points and an uncountably infinite amount of points. So to loop over every single possible location in Columbus is not only impossible but just pointless. So we believe that taking a random sample of 50 points was sufficient to find a relevant answer and also keep the runtime to a minimum. You can see some pictures there. Those are just small samples of restaurants, hotels, and bus stops within the Columbus area. We took the entire Columbus area at large and took all those bus stops and everything and used them to find a problem formulation. So just a little sidebar, when actually calculating distance between 2 points on a 2D space, that's not a linear function, so we decided to make it a linear function by using a different method of the distance. We decided to use the version of distance called the Manhattan distance. That's just the difference in x, or the distance in y, or like the amount of space you would have to walk in an x direction, and then the amount of distance you would have to walk in a y direction, or like one walks through Manhattan. And we thought that was relevant because you cannot walk between two substantially distant points in Columbus in exactly straight line. It's just impossible with buildings being in the way, so on and so forth. After running our code, these are the results that we found. We found that the minimum distance between all of these points was at latitude 40 and longitude 83, with some decimal trailing there, with the objective function of exactly 166.17. That's like distance differences in longitude and latitude. Putting this point into Google Maps, you'll find it's on East Hudson Street, right off North High Street. Kebab time Mediterranean food is right there, a bunch of restaurants. Here's the bus stops, and then you have some hotels that are also nearby. So that's the exact point. Thoughts on this this project at large? In the future, in order to get rid of that infinitely large amount of points, you could just say, hey, here are 50 prospective points for a stadium location. Then you could run this program on it, and then you could be able to, you could even tweak the code as you wish to say like, hey, what if we wanted 15 restaurants, or what if we wanted 2 bus stops for, or also be able to say we want a bus stop that's going to the east and we want one that's going to the west, or one that's going to the airport and one that's going to downtown. Like you can have all these things and also mesh that into a problem. We found the asymptotic runtime of the algorithm we need was in big O of n. That's just saying that for the amount of points that we put into the algorithm, it's only increasing the runtime of the algorithm. The maximum runtime of the algorithm is only increasing linearly, so we don't have to worry about for adding more points that the algorithm we used was actually more cumbersome. And also, so that just also implies that the runtime just becomes linearly harder with additional points that we could have. So that's our project. We found this location. I really like this project, and I actually found that the perfect spot for a new Columbus Crew location was actually about 450 feet away from where I live. So thought that was cool. I thought you guys would like that, and thanks for watching.